Hey guys, welcome back. For purposes of taking notes today, you can either download the PDF that is in this HyperDoc, or I'm going to assume you don't have a printer and maybe you just have notebook paper. So I'm going to give you the notes just by going through, kind of thinking that you have notebook paper. So we are actually starting today with what we left off right before we left on this break that we've been on. Now I know the last couple of HyperDocs were review material, and the last optional HyperDoc that you had during spring break was actually the last lesson we had, which was on simplifying radicals. So if you forget how to simplify radicals, or at least the first day of it, it's highly recommended that you go back and you redo that so that you know you're not really lost. But if you think you remember it, or if you did it the review over spring break, that was great. But I'm just going to kind of continue on and see if you can remember it. So I'm going to write down the first example that we have, and you should write this in your notes. Okay, so this is under the radical, we have 4x squared y to the third power. Okay, so we learned about the index. Now in this case there's nothing right here, so we know our index is 2. So it's like the square root. So the coefficient piece, if you think about it, the square root of 4 is a perfect square, so the square root of 4 is actually 2. So the number piece, the coefficient piece, is kind of easy. It's already a perfect square. Now x squared, if we had two x's, okay, we wanted to find out, since the index is 2, okay, the square root of x squared would just be 1x, okay, and then if we had 3 y's, we would actually have one pair of y's with a leftover y. So what's left over would just go back under the radical like that. Whoops, that would be a y. Okay, so let me just finish that up. So that's your first example, okay, and then we would be done with that. Okay, number 2, all right, let's write down number 2, and number 2 is a little more difficult. We've got 300 m to the 4th n. Okay, so now the number 300, the coefficient, we actually want to try to put that in simplest radical form. So what we did before break was actually we broke the number 300 into a series of prime numbers, and we did it by coming up with factors. Okay, so 300, we could start with 300 times 100. Okay, and 3 is prime, so I'm going to circle it. 100, we can say 10 times 10. And then for 10, we could say 5 times 2. There's 5 is prime, 2 is prime. Then we have 5 and 2. Okay, so now to look for the perfect squares, notice we have 2 5s and we have 2 2s. So we're going to take the 5 out. There's our pair of 5s and our 2 out, like that. Okay, and then left inside the radical, we just have a 3. Okay, so that would be the first part with the coefficient. Now the second part, we've got m to the 4th, so looking at our variables, if we have 4 m's, there's actually 2 pairs of 2. So this would be m squared, because there's 2 of them, and then what's left over would just be the n. So now I'm going to kind of put it close together. 5 times 2 is 10, m squared radical 3n. Okay, so we just put that in simplest radical form. Okay, so now moving on, okay, we've got number 3. Now number 3 has an index of 3. Okay, so it's not going to be the square root, it's actually the cube root that we're looking for. All right, so we're going to start with the coefficient piece, which is the 54. We're going to say, well, 54, let's multiply 9 times 6. And 9, we can do 3 times 3. Let's circle those because they're both prime. And then 6 is 3 times 2. Okay, so since we're looking for the cube root, this index right here is 3, we look for our triples, not our doubles. Okay, so we're going to take the 3 out because we got a triple 3, leave some space for our variables, and then we're going to write the radical sign. The 2 is actually going to stay underneath the radical because it's the cube root of 2. All right, looking at our variables, we've got 7. So 1, 2, 3, 4, 5, 6, 7. Now because our index is 3, we're actually looking for our triples. Notice we have 2 sets of triples, so our x is going to be to the 2nd power for the 2 sets, and then we have 1 x left over like that. Okay, and then y to the 6th. Okay, and you can also think of this as just 6 divided by 3. 6 divided by 3 is 2, so we know our y is going to be squared. And we don't have anything left over, okay, once we have our 2 sets of 3. Okay, so that would be our final answer. And don't forget to write that little cube root in. That's really important. Okay, so another example we'll do will be number 4. So I'm going to give us a new page, clear the page off to make some room for number 4. Okay, so number 4 is negative 3 times radical 125 x to the third y to the 6th. Okay, notice we have a number outside of the radical, negative 3. We're going to bring that down to the bottom so we don't forget about it because we want to multiply that at the end. Okay, so 125, well, let's think of money, quarters. 5 times 25 is 125. Okay, and then we got 5 times 5. All right, so for the coefficient piece, we're looking for our doubles because our index is 2. There's nothing there, so we know it's 2. 5 times 5, so the 5 is going to come out. Remember, we're going to multiply that by that negative 3 at the end. So we took care of those. We have 1 left over 5. Okay, now our x's, we've got 3 of them, so our index is 2, so we're looking for how many pairs, which would be 1, with 1 left over. And then y to the 6th, so if we had 6y, okay, and we're looking for our pairs, it would be 1, 2, 3, so y would be to the third power. So now we multiply that negative 3 times 5 and we get negative 15, x, y to the third, radical 5x. Okay, so at any time, I'd like you to just pause the video and try a few. So let's try number 5. Let's write it down, and then you can pause it and give it a try, and then I'll explain it. Okay, so this one has a negative on the outside, and it's actually the cube root of 96 m to the 7th n to the third. Okay, so you're finding the cube root. So again, pause the video right here, try it, and I'll continue on. Okay, so 96, I know it's even, so it's going to be 2 times 48, so 2 is prime. 48, I can do 6 times 8. 6, I can do 3 times 2. Okay, 8, I can have 4 times 2, and then 2 times 2. Okay, it's a little more complicated. Okay, because we're looking for our triples, because the index is 3, we're not going to forget about this negative. That's going to be multiplied at the end. Okay, we got a triple 2, so 1, 2 gets pulled out. And then we have 2 2's left over. So 2 times 2 is 4, okay, and then we have a 3, okay. All right, so we took care of our prime numbers. M to the 7th, so if we had 7 m's, you can think of it as, let's see, 1, 2, 3, 4, 5, 6, 7. 7 divided by 3, because we're going to put them in triples, would be 2. So our m would be to the second power with 1 m left over. Okay, and n to the third, well, we're just going to have one set of 3's, so that's going to go on the outside. So then our final answer would just be negative 2 m squared n. I'm not going to forget about the cube root. The cube root of 4 times 3 is 12, and then m. Okay, and then for number 6, we can do it the same thing. I'm going to write it down. I'm going to have you guys try it and then pause the video. So negative 4a, and then we've got 24, a to the 5th, b to the 6th, c to the 8th. Okay, all right, so pause it here and then come back. All right, now I notice my index is 2, so this I could say 2 times 12, and 12 is 2 times 6, and 6 is 3 times 2. Okay, on the outside we have a negative 4a, so we're going to bring that down and not forget about that. All right, so we're looking for our doubles. So we've got 2 times 2, so there's one set of doubles. So we're going to multiply that by 2 on the outside. And then left over, we have 3 times 2, which is 6. So that's going to be left on the inside. Those are the ones we couldn't double up. All right, now our variables, we've got a to the 5th. Our index is 2, so we have a would be squared, and then we'd have a leftover a. Our b, we have 6 of them. Okay, and so we're looking for our doubles. We've got 1, 2, 3. So b would be to the third power. And c would be to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Okay, again, we're looking for our doubles, so you can actually just think of it as 8 divided by 2, which is 4. So c would be to the 4th with nothing left over. Okay, so now I'm going to simplify what's on the outside. Negative 4 times 2 is negative 8. A to the first times a to the second would be a to the third. B to the third, c to the fourth, radical 6a. There's your answer. Okay. All right, so now we're going to move on a little bit. All right, and what we're going to do right now is we're going to think about, for number 7, we want to know what value, okay, can be placed under the radical symbol to make it true. All right, what does that mean? Okay, so here we're going to go backwards. So I want to know if I had a blank radical and I said the simplified version is 2 radical 5. Okay, there's a dot there. Let's make sure. Let me clear that out. I've got some funny things on here. Come on. Okay, so we've got this as 2 radical 5. Okay, so what would go there? All right, so essentially what we're doing is we're taking this 2, it's on the outside, and we're putting it back in. Okay, now if we wanted to put it back in, we have to think of the inverse. Instead of the square root, to go back in, you'd actually take the 2 and you'd square it and then multiply by the 5. Okay, so 2 squared would be 4. 4 times 5 is 20. So the number that would go inside would be 20. And if you wanted to check it, you could start with radical 20 and simplify it. All right, so I got 4 times 5 and I've got 2 times 2. All right, so think about it. How many pairs of 2 do I have? 1, that would be on the outside, with 5 left over. Okay, so we're kind of going backwards. So in order for this number to go back in, because my index is 2, we're just going to square what's on the outside and multiply it by what's on the inside. Now if my index here was a 3, then I would actually cube it to go back in. Okay, and that's going to be the example we're going to try on the next one. Okay, and so for number 8, okay, now number 8, we want to know what is the value going to be. So we've got 2x and we've got the cube root of 5x. Okay, so don't get confused, that's not x cubed, it's the cube root, okay, of 5x. Okay, so what we want to do here to figure out what would go underneath the radical to make it true, so we want to look at this and say, what would that be? Okay, all right, we've got to take what's on the outside, this 2x, and put it back on the inside. So to do that, we're going to take 2x and we're going to cube it and we're going to multiply it by 5x. Okay, so now we're following our rules of exponents, and this 2 would be cubed. The x would be cubed times 5x. 2 cubed would be 8x to the third times 5x. Now we multiply and we get 40x to the fourth. Okay, so 40x to the fourth would be what went underneath it. That would be our answer. Okay. All right, so a little difficult there. All right, so we're going to try one more and see how you do with number 9. Okay, number 9. All right, so number 9, we've got 3xy squared radical 2y. Okay, and we want to know, okay, what is that equal to? What would go under the radical? Now the index here is 2, so why don't we pause right here and try this and then see how you do. Okay, so coming back now, we're going to take what's on the outside and we're going to put it back on the inside. Our index is 2, so we're going to take everything on the outside, 3xy squared, and we're going to square it. And then we're going to multiply it by 2y. 3 squared is 9, x squared, y to the fourth. I took every factor and squared it, and I multiplied by 2y. 9 times 2 is 18. Okay, we've got x squared, and then y to the fourth times y is y to the fifth. And there's your answer. All right, so I hope this helped. At any point, I want you to go back and try to review, okay, or email any questions.